Hello, welcome back once again. Today we are in the complex world. So here we're going to find the square root of the imaginary unit, iota. So we have the square root of iota is equal to what? And here we're going to find this principal square root, right? So let's get started. So we're going to start by let the square root of iota equals a plus ib. You know why? Assuming the square root is going to be complex, right? So now what is the next thing to do? So we're going to square both sides to get rid of this root sign. So let's square both sides. So we get the square root of iota squared. This is equal to a plus ib all squared. We know that a here is the real part and b here is the imaginary part. So now expanding, this square, we cancel the square root. So we have iota is equal to, here we get a squared plus ib squared plus 2 times a times ib. The identity we made use of here is this identity that a plus b squared is equal to a squared plus b squared plus 2 times a times b. And again, let us recall that iota is equal to the square root of -1, right? So if we square iota, then we get the value for it as -1. So here we get iota is equal to, here we get a squared. So here I squared is -1, then times b, which is times b squared, which is -b squared. Then we have here plus 2 times a times iota times b. That will give us 2i times a times b. So in our next step, let us show that this imaginary unit here, which is iota, also has a real part, right? So we're going to do that by rewriting it as 0 plus 1 times iota. So the real part here is 0, while the imaginary part is 1. So this is equal to a squared minus b squared plus, now let us show the imaginary part here, which is 2ab. Then we have this imaginary unit. So from here, we're going to compare. So here we have this real part here, which is this a squared minus b squared. So we compare as follows. A squared minus b squared is equal to the real part here, which is 0. So from here, this implies that if you add b squared to both sides, that a squared is also equal to b squared. Amazing. Then the imaginary part, we're going to compare them, right? So we're going to equate them, So here we get 2ab is equal to 1. Then when you divide both sides by 2, we get that AB is equal to 1 divided by 2. Okay. Now we know that a squared is equal to b squared. This also implies that a will be equal to b. Is that true? If a squared is equal to b squared, yes, a will also be equal to b. But in some cases, a will not be equal to b. What if a is equal to -1 and b is equal to 1? Then we can say that the squares will be equal, but their sum, but if you equate their that is their first power, they will not be equal because -1 is not equal to 1. So should we say that a is equal to b? No, let us not yet do that. Okay, so let us continue from where we stop. So a squared is equal to b squared. So let us substitute here, right? So we have a times b is equal to 1/2. Here we have that a squared is equal to b squared. Okay, there is something really cool we're going to make here. So if a squared is equal to b squared, then we have some cases where a will be equal to b. and we have some cases where A will not be equal to B. So let's use this case where A is equal to B. So by so doing here, then we got A times B, which is equal to 1 over 2. We substitute the value for A in terms of B, then we get B squared is equal to 1 over 2. Now when we take the root of both sides, so we get B is equal to plus or minus the square root of 1 over 2, which we can write as plus or minus 1 over root 2, because square root of 1 is 1. Then let us recall back again. You remember we use the case where A is equal to B. So we get here that when B is equal to 1 over root 2, this implies that A will also be equal to 1 over root 2. Then when B is equal to negative 1 over root 2, this also implies that A will be equal to negative 1 over root 2. Now let's go back to the main problem here. So remember we initially let the square root of iota to be equal to A plus IB, right? And we are interested in finding the principal square root, which means it is going to be positive, right? So for this implies that we're going to use the value for A 1 over root 2 and the value for B 1 over root 2. So from here, this implies that square root of iota is equal to 1 over root 2 plus iota times 1 over root 2, which is equal to 1 plus iota divided by root 2. So therefore, we come to the end of today's video that the square root of iota is equal to 1 plus iota divided by the square root of 2. And this is the correct answer. Thank you for watching. Please kindly subscribe to my channel. Also like, comment and share. Bye-bye.